I'm making a second video because when I did 26 and 27 the first time, I made a mistake. So I'm gonna splice things together. All right, look at this one. Man, you wish this was log base too. So do I. When I first saw this, I was like, actually trying to Google something. And then I figured it out. And there's actually different ways to do some of these past problems that we did where, um, yeah, these, you could use like, there's ways to do like change of bases. That's going to help us. Let's remember, you can write log base 4 of x as the log base uh, star of x over the log base star of 4, right? Change of bases. Well, I want log base 2 because I got x plus 1 in here, and I don't want to mess up that. So what I'm going to do is actually rewrite this log base 4 as log base 2 of x over log base 2 of 4. And then I realized something. Log base 2 of 4. What's that? Log base 2 of 4. That's something. Take 2 to the power of both sides. 4 equals 2. Okay, that's 2. So all of a sudden, I've just changed this to be log base 2 of x plus 1 minus log base 2 of x over 2. Okay, great. Well, instead of divided by 2, why don't I write this as times a half? And why don't I put this as an exponent? And why don't I combine the things by division using log base 2 of the left divided by like the one on the right? So I'm going to do that. All of a sudden, I have log base 2 of x plus 1 over x to the 1 half, or the square root of x. That equals 1. All right. Well, let's square both sides. And I get 2 to the power and 2 to the power. The 2 to the power will get rid of the log base 2. I get x plus 1 over root x equals 2. Okay, I am going to move everything onto the top. So I'm going to multiply everything by x to the 1 half. I get x plus 1 equals 2 x to the 1 half. And now I'm going to square both sides. Why? It's like, just to get x to a certain power, like if I get x squared, which I'll get on the left side, then it's a quadratic. Sometimes you don't want to square both sides. It means you could have like when you square root, that'll give you the plus or minus. I think we're going to be fine squaring both sides. Okay, be careful. When you square the right side, it's not just going to be 2 times x. It's going to be 4x. The left side, x plus 1 squared, is x squared plus 2x plus 1. We know that because it's x plus 1 times x plus 1. Now, when I subtract 4x, I get x squared minus 2x plus 1 equals 0. Oh, x minus 1, x minus 1. Those are the two numbers that add to get negative 2 and multiply to get positive 1. Give me an answer of 1. Log base 2 of 2 is 1 minus log base 4 of 1, which is 0, is 1. Look at that. I'm laughing because the answer is easily seen if you just kind of guess a couple numbers. But then look at all this work we got to get it. But that's what we got to do. Okay, this is fun. These are cool puzzles. All right. Let's look at this guy. Log base 2 of 3x plus 2 minus log base 4 of x. Let's change that log base 4 of x to be something with a log base 2. Hold on. My cursor just is freaking out of me. My computer's been slow today. Whoa. Gmail's been slow. All right. log base 2 of 3x plus 2. Change bases. This is log base 2 of x over log base 2 of 4. Remember, log, change of bases. Oops. It'll catch up, but right now it's really lagging. Log base a of b equals log star b over log star a. All right, and that equals 3. We can go through this entire process, but we can kind of skip because we just did it for the last one, but it's good to show like where it comes from again. So I got log base 2 of 3x plus 2 minus log base 2 of x over 2, which equals 3. This becomes a 1/2. Maybe I'll just write all this stuff out. Log base 2 of 3x plus 2 minus 1/2 log base 2 of x. Move the 1/2 up. Maybe my cursor will come back soon. Log base 2 of 3x plus 2 minus log base 2 of x in the 1/2 equals 3. Rewrite this, log base 2 of 3x plus 2 in the numerator divided by x to the 1/2 in the denominator. That's using log properties equals 3. We're ready to do 2 to the power of both sides to get rid of the log base 2. Gives me 3x plus 2 over x to the 1/2 equals 248. And then multiply both sides by x to the 1/2. I get 3x plus 2 equals 8x to the 1/2. I'm ready to square both sides. Yikes. Let's do it. I get 3x plus 2 times 3x plus 2. So 3x and 3x is 9x squared. 3x and 2 is 6x. 3x and 2 is 6x, so that's 12x. 2 and 2 is 4. Here, 8 times x to the 1/2 is 64x. Subtract 64x, 9x squared. 12 minus 64 is 52. Plus 4 equals 0. 9 times 4 is 36. So there are two numbers that multiply to get 36 and add to get negative 52. Whew. Not 26 and 2. I feel like this is another quadratic formula one. I'm going to go back to the old days of graph to solve. 9x squared minus 52x plus 4. When does that equal 0? Find the intersections. 0. That's not 0.
Maybe quiz the old plan first compared to.
I'm recording right now. Yeah, this is total quadratic formula. All right, I'm just going to list off the quadratic formula. X equals the opposite of b plus or minus the square root of b squared. What's the exact answer? Minus 4 times a times c all over 2a. Whatever this value is, this is the answer. Yeah, these are tough, these last two, because you got to use change of base to make log base 2 of 4, and to write log base 4 of x into a log base 2, and then you use exponent properties, and then we kind of end up squaring both sides. We hope to factor. Sometimes we can't factor. But yeah, that's it. It's tough stuff here, pre-calculus. Raising the bar here, guys. Getting you ready for AP calculus. Later.